This is the sixth and final video in the block design project. We've been working in our assembly file to create geometric rules to hold our different parts together. We're going to continue with this, but before we get started, we're going to notice that we can still move this object freely. If I right-click on it, I can fix it. What that basically means is I'm going to pin it to the ground. Which allows my part not to float randomly around the screen. So now you look when I grab it, it doesn't move. I'm going to insert now my cylinder, clicking into the workspace and bringing it in. What you're going to notice is the cylinder will move because there's no geometric rules attached to it. But this piece won't because we pinned it, and the other pieces won't move because they're attached by geometric rules to the original piece. So we're going to explore some other constraints this time. And we've done the fastened. This time we're going to go to the Revolve Mate. So I'm going to select the Revolve Mate. I'm going to select the center of the top here and the bottom center of the cylinder. Green check mark to confirm it. And what you're going to notice now is the cylinder actually spins or revolves. So it's connected on the axis, but it can revolve around it. Now, if we fasten this piece from the bottom face to the bottom face center points, the piece wouldn't revolve. It would just be there. This is just an option depending if you want motion in your assembly, and this will be valuable for later on projects. The next thing that we're going to do is we're going to insert a cylinder again. And now we're going to come to the slider mate. So again, I'm going to choose that top surface and the bottom surface. I'm going to agree to those constraints. But now what you'll notice is that part is only locked in on two planes and it's allowed to slide past each other. Now again, for this project, this probably is not a constraint that we're going to want, but is just an option to show you. So I'm going to actually delete that slider constraint, move this part off, and I'm going to show you the cylinder mate. Again, I can choose that face on the bottom or the top and the bottom at the center points. I'm going to solve, again, gain perspective. And what you're going to notice is in the cylinder mate, because we're dealing with circular objects, it works very much like the slider mate. The slider mate can work on parts that are square, rectangular, while the cylinder mate generally works on cylinders. But again, I'm going to delete that. Now that constraint, move this part off. Now to show you what the Fastened Mate will do, I can simply click on the Fastened Mate like we've learned in the past, click on that center point and the center point, green check mark. And what you'll notice now is we're locked in on all three planes because we're fastened to those points. But because this one can still spin, I know it's difficult to see, both of these parts would spin together because the top cylinder is fastened to the bottom cylinder. Now, lastly, if we take a look at this project, depending on your grade level, the rules for this will differ. This video is for 6th, 7th, and 8th graders. So please look at your document. This is the 8th grade document. You are to design a structure using 4 different types of cubes at a minimum and at least 12 cubes constrained together. So again, start off in your paper and pencil, draw your sketch of what you'd like to design, and then bring those parts together to create. These are 2 examples, and please do not copy these. And again, each grade level will have a different set of constraints.